I lost the. Okay, I have it. Okay. Are we good? Okay, so the technical introduction to blockchain technology will be my presentation. I'm Konrad Rotkiewicz, CEO of the Ulam Labs, the software house here in Wrocław. We are mostly specializing in the Python applications, but recently did a couple of projects with blockchain technology, and this is the reason I could present some of our knowledge experience here. So all the blockchain works pretty much the same as, and I will be trying to focus not to talk about any particular one. Understand they are quite similar, like I said. Understanding first one gives you the 90% of the knowledge. Understanding any next one is pretty much quite easy. Each one of them is differs a little bit. So it's quite awesome technology. So I really encourage anyone to learn, like, let's say various one of them. In Ulam Labs we have the direct experience in Bitcoin, Ethereum, Ripple, and EOS, and some theoretical experience in Ethereum 2, Tezos, and Algorand. And so I will be basically the most of today's presentation will be based on those ones, on the experience from these ones, Okay, so like I said, I will not talk. I will try not to talk about any specific blockchain technology today. Okay, so first thing is the basic question: what is the blockchain and how to understand that? How to understand it? I would say that you should think about it in the two ways. First one is as a data structure, which is basically the blocks that links together. They formulate the blockchain. And this way, they store some kind of the information. That we can use. But also, blockchain is a network. That consists of the nodes. So basically, the nodes exchange the information and they participate in the protocol. Creating the blockchain structure, data structure itself. So let's start with the data structure of the blockchain. And then the most basic one is obviously the transaction. It defines who pays to whom. The transaction to be valid and accepted by network has to be signed by the owner. And then after signing, the transaction can be submitted to the network, and only after signing the network can accept it, like I said previously. From the development perspective, the quite important part is of the blockchain network is the mempool where all the transactions go. So the transaction goes to the mempool, and then it's included in the blockchain if it how to say that like obeys specific requirements. So let's call it like that. So let's talk a little bit about the mempool. It is, like I said, first place where the transactions is stored. It is you can think about this as it's called mempool, but it's always stored in the disk in all nodes, and then this mempool is synchronized between the nodes, all nodes keep all new transactions in this mempool, and okay, so the next part will be the node itself. The node itself, basic role is to connect to other nodes and exchange the information. All of them, they create the blockchain network, and there are two things that they exchange. Yeah, first thing is they synchronize the mempool, and the second one obviously is they synchronize the blockchain itself. Yeah, and the third one, that quite important for us as our developers, is that it gives you the interface to the development interface to users, and this is in most of the blockchains is the two different interfaces. One is the JSON RPC, where you can, let's say, submit a transaction, or you can ask the node for some particular data, like for example, give me a latest block, yeah, or give me transactions for the given address or given user, yeah. The other one is the WebSocket, where you can subscribe and listen to the different events. Like, let's say there is a new block, there is a new transaction, yeah, there is an event that happened on the network, yeah. So here it's the types of the things that you can subscribe highly depends on the blockchain type itself. Yeah. Okay, so basically how the mempool, I prepared some kind of fancy animation how the mempool itself works. Yeah, it's quite easy. Yeah, and how the mempool affects the developers. So let's say that we have the Alice and we have the Bob. They both are developers, yeah, or users of the network. Yeah, and let's say that the Alice is submitting a transaction to the node, yeah, and the node, what it does, it stores the transaction in the mempool and propagate the transaction to the other nodes so they can store it in the mempool, yeah. So this mempool, as we can see, is synchronized between the nodes, yeah, and this is the first step, often missed when explaining the blockchain itself, yeah. So then, obviously, after the transaction. After the transaction is propagated, yeah, the subscriber, which is here is the Bob, yeah, it can get the notification. So you can, like I said, you can subscribe to many things. Here, the Bob subscribes to new transaction. That is not yet confirmed, yeah. So it still resides on the mempool, yeah. And from other end, yeah, what we can do, yeah, it's like the same, yeah. The Bob can submit a new transaction. It is propagated, yeah, and Alice can receive the WebSocket notification or message, yeah. Yeah. So this is the mempool. What next part is the blockchain. The block structure itself. Yeah. So basically, what it does is it combines the transactions together, so that when we have the blockchain network, we don't need to send the transactions directly, because it will be difficult to do, because the time difference between the one transaction to another will be like really small, and then it will be really hard to catch what is the latest transaction to submit the next one on top of it. Yeah. So what the blockchain authors did is that they propose to create a block where you can put many transactions, yeah, and that block will be propagated to the network, yeah, which means that the bigger the block, yeah, let's say, the slower it can be transmitted to the network, yeah. Then impose some of the limits to the structure and to the network itself, like I said, how many transactions can be stored in the single block. Who and when can propose next block? Who can propose the next block, and when it can happen, or how often it can happen? Yeah. Then obviously the block itself is synchronized between the nodes, and it formulates the blockchain by pointing to each block has to point to the previous block, and this way it formulates the blockchain itself. Yeah, and how it works from the from the network perspective is that let's say that we have the classic small blockchain network. We can see that we have each node has a free transaction in mempool. Each one has a free blocks already created, and Alice is the observator or the developer waiting for some kind of the events. So what could happen is that let's imagine that the third node is proposing the new block. It takes the two transaction. Let me repeat that. It takes two transaction and creates the fourth block, and this fourth block can be propagated. Let's say to all the nodes. But in this example, let's think that it can be propagated just to the neighbor node. And what happens then is that this node has to validate the block if all signatures are included. If the block proposer is valid one, and then after checking all the constraints, what it does, it removes the corresponding transactions from the mempool. And the same happens to the other nodes. So the block is propagated, and other nodes has to do exactly the same. And then obviously Alice is listening on the WebSocket, and here it receives two notifications. One is that there is a new block, and other one is that there is a let's say new transaction, that it subscribes to. Okay, so this one, and then so someone could ask, okay, so we have the blockchain, we have the mempool, So where are my money then? Where are they stored? How to access them? How to see them as a developer? Let's say. So let's imagine that there is a node. It has three blocks already received. And what the node does itself inside is that it has to index, or we could call it, it has to store the various data in a local database as a form of the table. We can think about this as a table, but it's mostly not a table because the SQL databases will be quite slow in this case. So what most of the blockchain nodes do is they use probably, as far as I remember, the level DB or the rocks DB, which are the key value quite fast regarding the throughput, quite fast key value databases. But at the end you can think about storing the extra data in the form of the tables. So what happens is that when the new block arrives, it extracts the transactions and put them into the database, so that it can be easily queried either by the user if let's say if the user requests the all transactions for Alice, or for the validating next blocks. Because imagine that we have another block arriving, and then we need to validate. We need to validate if the let's say all the transactions are valid in the way that they have a proper balances. That let's say proper input balances. Or how to call that. So it needs those kind of information in quite fast form. To accept the new blocks in efficient way. The same is with the mempool. So let's say that you are submitting a transaction. It goes to the mempool. It's propagated to the node, and then this transaction, the node has to check if this transaction is valid one. By valid, you need to check not only the signature, but also if there is a correct amount of the money left on the given address that it will be subtracted from. The transaction will subtract from. And then you can see that we also have to update the balances. Yeah, probably the balances are stored in the separate index, just to have a quick access to them. And then the same operation continues. Yeah, with the block 5, we update the balances. Yeah, the node updates balances. The node 6 updates the balances. The block 6, block 7, yeah, adds the transactions, yeah, update the balances, yeah, and so on, yeah. What could happen here in this case, and what the blockchain developers has to remember is that in some of the blockchain types or blockchain networks, yeah, the blocks could be, or part of the blockchain could be overridden. Yeah, so it means that we have to prepare our application so that when let's say 2 or 3 blocks will be reverted and new will be submitted. Yeah, so what we need to remember is that those transaction history and account balances will change. Yeah, so the simplest way obviously is to wait for the safe number of confirmations. Yeah, but often what happens is that you would like to give a user like a immediate or instant notification that something arrives. Yeah, then it could disappear. Yeah, looking at just basically on the node itself. Yeah, so it has to. This is like a quite difficult thing to remember when, let's say, when you are preparing some kind of the crypto exchange or something like that. Yeah, that normally, let's say, in the Bitcoin network, waiting, let's say, 5 confirmations is enough. Yeah, but yeah, you never know. Yeah, you should always have some kind of the protection. Yeah, if there will be an attack on the network or something like that. Yeah, more than 5 blocks will disappear or something like that. Yeah. What else here? In other blockchains, yeah, they prepare the blockchain itself so that you can't basically modify the blockchain itself. Yeah, probably as far as I remember, it's called the immediate finality, and for example, probably it's in Algorand. Yeah, that you don't need to think about that. Yeah, because they have the instant finality. It means that when you accept the blocks, yeah, you are 100% sure that it won't be overridden. Yeah. Okay. So let's move further. Yeah, the one note is that when someone is talking about the distributed ledger, yeah, so basically the ledger is this part of the blockchain, which means that it's like the ledger itself is just the history of the transactions. Yeah, you can store it in the database. But also, yeah, it's like when you look at the blocks, yeah, and the transaction inside it, yeah, it's as a ledger, yeah. That one. This is basically that. That's all. What I could tell is that the other things worth asking, yeah, is that who can propose a new block, or how often the new block can be proposed, yeah, or what happens if there's a conflict, yeah, like the 2 different blocks are proposed at the same time, yeah. Those questions basically cannot be answered in generic way because it differs between network to network or blockchain type to blockchain type. Yeah, I could say that most of people probably are familiar with that. Yeah, that you can do some of blockchains. They do consensus in the way that it's called proof of work, and it's answering those questions. So basically, answering the question who can propose new block or how often it is proposed, the protection for the network protects itself in the way that the one who will be proposing new block has to solve the cryptographic puzzle, which basically means, probably it's quite easy to understand for the developers, because it basically means that when you have the block already prepared in a way that you take the transactions from the mempool and put them into the block. So what you need to do next is that you need to calculate the hash of that block. And to calculate the hash, you have one field, which is it's called nonce, but basically it's a placeholder, So what you can do is I have it. This is here's the nonce, So what you have to do is this is a placeholder value, which means you can put any integer there, and then you are calculating the hash of the block, So what you can do is, what you have to do is you need to find the nonce that will that the hash of the whole block will achieve certain number of the zeros in the beginning of the hash. So basically this is how the proof of work works, and it's like, as you can imagine, it's quite difficult to do, because basically what you have to do is you have to iterate nonce, from 0 to the million on tenth of millions, calculate the hash until you will find the hash with the, let's say, 20 zeros, and then you can propagate that block to the network, and network will accept it, and it's very easy to verify this hash by just checking the hash yourself, and then the other one is the proof of stake, consensus algorithm, and this one is, let's say, more modern one or newer one, used by the modern blockchain types, like EOS, Algorand, Tezos, or Cardano. And basically, in this case, to be able to propose a new block, you have to possess or you have to have certain amount of coins in your wallet, and then you can be elected to as a block producer, and then you can produce or propose a new block. So so basically the block producers or the proposals are randomly chosen from the coin holders. The more coin you have, the more often you will be elected. And the exact implementation varies from the blockchain to blockchain. So, for example, in the let's say in the EOS is that the block producers are you delegate your coins to choose the producer, or and in the Algorand what you do is there is a special cryptographic function that works like a lottery, and then it works in the way that, as far as I remember, that the election of the next blockchain proposal is done in the way that only the proposer can tell if it is if he won the lottery or not, and nobody else can check that until the block arrives, and then it can be verified. It's called I don't remember right now. Random. I don't remember right now. So these are the other things worth asking. And for the proof of stake is like a proof of work is quite, let's say, it works the same from blockchain to blockchain. For the proof of stake is that it's each implementation varies a little bit, and they call it even different ways. Yeah, like the DPoS, which means the delegated proof of stake, LPoS, which means this is the liquid proof of stake, or PPoS, which means the pure proof of stake. Yeah, I strongly recommend looking on those. Yeah. Okay, so this one, and then what we have? Oh, yeah, we have the last slide, because that's all, and yeah, obviously I can answer questions here. Yeah.
We have one question.
Only one. Okay. Okay. What's the impact of the block size on the network performance? Yeah. So it's quite important. The block size is quite important on the blockchain performance itself. Yeah, obviously the bigger the blockchain, the faster the network is, because then if you have in the mempool you have, let's say, 1 million transactions. Yeah, if you could put them into a single block, yeah, and then broadcast it to the network, yeah, then this means that the network will be faster. Yeah, so you could access the throughput of the network, which is the amount of the transactions per second, yeah, will be higher. But it's also a dangerous thing. Because the bigger the block, yeah, the easier it is to attack the network, because then someone could it's harder to the larger the block, more time it takes to verify the block itself. Yeah, so this was the war between there's a constant war between the Bitcoin and Bitcoin Cash, because the Bitcoin Cash wanted the block to be bigger, so sacrificing the security for the performance, and Bitcoin itself was more conservative. Yeah, so it wanted more security than the throughput or performance. Yeah, so yeah, probably that answers the question. Okay, cool. Yeah, I was quite fast. Yeah, probably. Yeah, maybe it would be better to watch it on the slow, more like half of the speed. Yeah. Okay, thank you.
So we need 5 more minutes to switch to.
Yeah, we need 5 more minutes. Yeah, obviously. Okay.